Hello, welcome to our data mining project presentation. We are Group 14 and working on the German credit dataset. This page shows the project overview. The business objective is to understand the potential risks of lending money to customers and predict future risks to avoid potential financial loss. Univariate and bivariate analysis are done. Business suggestions are given. This is the dataset overview, the definition and interpretation of each variable. We have 10 variables in the dataset in total, and we attribute the data types into double and character. This page shows a summary of attributes after the initial analysis. We separated the variables into three types. Character variables used as factor attributes, numerical measurements, numerical variables used as factor attributes. Meanwhile, the variables are also classified based on their own definition and interpretation. From the summary, we can see that job attribute should be regarded as categorical. There is no obvious outliers, and there are relatively large amount of missing values in the saving account and checking account. We did a summary of individual attributes according to their definition. This is a summary of output attributes. This box chart shows that 30% of observed customers are rated as bad risk. This is a summary of customer identity attributes. There is an imbalance of gender proportion, and the age statistic follow a Poisson-like distribution. This is a summary of customer social information attributes. We can see that most customers own their houses, and most people are skilled. Very few people are unskilled and non-resident. This is a summary of financial record attributes. The checking account attribute means a large proportion of data, and most customers has little money in the saving account. The credit amount statistic follow a Poisson-like distribution. This is a summary of borrowing and lending attributes. We can see that in the duration attribute, there is a clustering pattern, and most observed customers borrow money for purchasing merchandise.
So let's move on to the bivariate analysis. In this graph, we notice that there's a positive correlation between the duration and credit amount, in which the value is 0.62. And also, we notice that there's a negative value, about negative 0.04, in which it means a negative correlation between the duration and age. Then here's an overview of our following analysis between the different attributes. But firstly, we give the definition on the risk about bad or good. And about the following attributions, there are sex, saving accounts, purpose, housing, checking account, and job. Furthermore, we'll give hypothesis tests to figure out what kind of statistically significant association will be selected. And going through this chart will further evaluate the correlations between the sex, housing, saving accounts, checking account, purpose, job, and duration. Going back to the previous overview, we noticed that between the female and male person always own more housing than female. And focusing on the checking account, we noticed that rich people on checking account may have more owned housings. So about the quite rich person on the saving accounts shows less likely to have the free housing here. Let's moving forward. There's not clear correlation with the saving accounts attribute between the sex and housing, but there's focusing on the checking account and the saving accounts, we figures out there's a distinctive positive correlation. Also, there's an interesting phenomenon that we noticed that customers borrowed money from radio or TV are more likely to own their houses and have richer saving and checking accounts. Kind of like these blue points we can see. Yeah.
Then we further analyze the hidden correlations among multiple attributes using split Bar-Ling plot. We first look at them under the same category. The left figure shows the distribution of age versus sex and risks. We can tell that the age distribution of female customers is more centralized than that of male customers. Customers rated as bad risk tend to have a lower average age despite gender. The right figure shows the distribution of duration versus purpose and risks. As you can see, the split plots for the two risk groups are notably asymmetrical. Interestingly, we found that when customers have little or moderate or NA checking account, their average credit amounts are higher for the bad risk group than the good risk group. On the contrary, when customers have rich checking account, their average credit amounts are lower for the bad risk group than the good risk group. A similar trend is also found in the saving account attribute. The most exciting finding is when we look at the credit amount versus purpose, as you can see on the right. We identify an abnormal combination. That is, when the customers borrow a large amount of money for vacation or other purposes, they are very likely to be rated as bad risk. We also try to group the duration into 4 categories in order to better understand their correlation with other attributes. Because as you can see, with the original numeric data, its trend versus other attributes such as credit amount is not prominent. But when grouping them, we can clearly identify the peak at 2 to 3 years duration category. In the end, we did t-test for each numeric attribute, and we concluded that with an alpha of 5%, there is indeed a statistically significant association between the risk and all the 3 numeric attributes. This is consistent with our previous bivariate analysis conclusions.
After exploratory data analysis and statistical testing, we proceed to predictive analysis and modeling for this data set. The first step is to deal with the missing data. We have a big chunk of missing data for both checking accounts and saving accounts attributes. And there are generally 4 approaches to deal with missing data. The second one and third one are generally considered not so efficient, so we majorly try the first one and the fourth one. Basically, we're treating the missing data as a new class none, assuming customer doesn't have any saving or checking accounts, or we try to use KN classification models to fill the missing data with the predicted ones. So we try different combination of features and different key values for KN models to get the best accuracies model for predicting saving accounts and checking accounts. But overall, the accuracies for both models are pretty low. And it can be due to we don't have enough data to train the model. Also, when we plot the numerical value data point in 3D plot, we can see there is no obvious clustering trend in this 3D space. That further verifies that the KN models doesn't work so well on predicting those missing values. So we decided to proceed with method 1 for missing data. After that, we began to set up our logistic regression model. Before that, we did log transform for all the numerical variables that are right-skewed to normal distribution. And then we check the correlation to see if there's any collinearity. After that, we did standard scaling for numerical attributes, and we split the data set into 80% training set and 20% testing set. So the first logistic regression model, based on the coefficient table and the p-values, we can see that duration, sex, customers' saving accounts amount, checking accounts amount are the attributes that are highly significant in this model. On the other hand, credit amount, age, job, housing, and purpose are not statistically significant at a threshold of 0.05 for p-value. And from this coefficient plot, we can observe a very wide confidence interval for high cardinality categorical variables. It basically indicates the instability. And we believe this phenomenon should be caused by having too little observations for each class in the high cardinality categorical variables. Consider we only have 1,000 observation in total for this data set. And we can see the logistic model gave us a 78% accuracy. And then we try to add all those interactions we concluded from exploratory data analysis. And we managed to increase the model accuracy to 80% after adding those interactions. And then we switched to a tree-based model. We use decision tree model as our first one. As we can see in this tree, the checking accounts is the most important variable. And if a customer doesn't have or have rich amount in checking accounts, there will be a very high chance, which is 87%, that she or he has a good risk rating. We can also observe this point from this variable importance table. Besides the checking accounts attributes, other attributes, saving accounts and credit amounts within customers' financial record grouping are also the attributes that are highly significant in this model. On the other hand, the customer's social information grouping, including attributes job, housing, are not so important. And we try different CP values to tune this decision tree model to get a better accuracy. And we find 5.5 times 10 to the minus 3 is the best CP to use for this model. But we get only get an accuracy of around 70%. It indicates that decision tree model doesn't work very well for this data set compared to logistic regression model. We further switch to random forest, which is a more which might be a more effective tree-based model for this data set. And from the conclusion of random forest model, we can see credit amount, checking accounts, saving accounts are still very important variables that determine customers' risk rating. And job, housing, customers' social background are still not very important for determining customers' risk rating. And we do have a 78% testing accuracy for random forest model, which is similar to logistic regression. However, we do have a risk of having overfitting in this model. In conclusion, all our three models suggest that the amount of money in the customer's checking accounts is one of the most important variables that determines the customer's risk rating. And both logistic and decision tree models indicate that as the checking accounts reach level goes higher, the more likely the customer would have a good risk rating. And besides checking accounts, the other two attributes in customers' financial records are also very important factors influencing customers' risk rating. From the risk decision tree model, it tells us that the customer that especially having rich amount in saving accounts or having credit amounts bigger than 1,200 and smaller than 7,000 is more likely to have good risk rating. Other than customers' financial records, duration and age are also very important factors determining customers' risk rating. And both logistic and decision tree models suggest that customer with bigger age but shorter duration will likely to have a good risk rating, and vice versa. And also, Our EDA report and this modeling, they both conclude that customers' social information, including job, housing, and also customers' sex, are not the key factors that influencing his or her risk rating. So when considering the factors that influence the customer's risk rating, we suggest the bank to place more consideration on factors within customers' financial records, customers' duration, and age, instead of customers' social information like job, housing, and also customers' sex. And that's all for our data analysis project. And thank you for your time.